Note, this video is part of a larger series on speed solving the FTO. Click the playlist link in the description to see the rest of the videos. I'm so glad it's finally here, everybody, my advanced video on last three triples. This is most probably going to be the longest video in this whole series, so I have added chapters and timestamps in the description so you can jump to exactly what you need. And I also don't advise watching this whole entire video in one sitting because there is a lot to cover. But hopefully by the end of this, you'll be able to advance your last three triples and go from something like this to something like this. Alright, so before we dive straight in, I definitely need to give a foreword on some important terminology and definitions for things, so that it'll be easier for me to describe specific cases and their properties. First of all, some abbreviations. CO and CP refer to the corner pieces in the last three triples, with CO being the orientation and CP being their permutation. So in this case, we have one corner oriented, so CO is not solved here. On the other hand, if both of these corners were oriented with the top color on top, then we would have CO solved. Also, here's an example where we have an unsolved CP because the corners are not permuted correctly relative to this top layer here. Even though they are permuted relative to the bottom, they are not to the top layer, and that's what I'm referring to when I'm talking about CP is with the top layer. On the other hand, this case that we saw previously does have a solved CP. Even though the corners are not oriented correctly, you can see that they are permuted relative to the top layer. So that is CO and CP. Now I want to introduce something to help distinguish the types of triangle pieces that we have within our three triples. We have bottom triangles and top triangles. The three bottom triangles are the three which have all distinct colors and surround that first center color, kind of like what I was referring to within the color scheme video I made previously. Whereas the top triangles are all the same color and normally belong on this last layer top face here. When solving last three triples, we only have to recognize bottom triangles and how they are arranged or permuted. Next is describing something I'm calling layer and global orientation and the difference between the two. So the layer orientation is simply how this top layer is oriented relative to the bottom. So in this case, this layer orientation is not solved. If we do a U prime, then it would be solved. And the global orientation is simply where the whole bottom of the puzzle is relative to the top. So for the purposes of this video, I really will only be describing the layer orientation, which is simply how this top layer is twisted. Finally, the last thing I want to describe is something called even versus odd permutation. And this has something to do with the bottom triangles and their placement on the puzzle. In this analysis, we're going to assume that each triple has its own separate triangle. And this actually is always possible to achieve by turning the top layer in some way. So, for example, here these two are in the same triple, but if I turn the top layer here to bring this top triangle over this bottom triangle, then you can now see they are all separate from each other. So here's an example last three triple state. This one has an even permutation of the bottom triangles. And the way that we can tell this is that if we look at each of the triangles, they are all permuted correctly relative to their bottom slot. Even though they may not be in the slot itself, they are either directly above it or they are directly in their corresponding slot. This is an even permutation because this state is off by an even number of two swaps of triangles. In this case, 0, because they are all placed correctly relative to their slots. However, here's another case, and this one is also an even permutation. Even though it looks like these triangles are no longer solved anymore, we can see that every single triangle is incorrectly off. The difference between this case and the previous one that I just showed is that all three of these bottom triangles are a 3-cycle off from where they were before. So effectively, this one moved to here, this one moved to here, and this one moved back to here. Note that this would require an even number of two swaps of triangles because first we would have to swap these two and then swap these two, because in order to get back, we would first have to swap these two to get this one here, and then swap these two So that way this one would go back to here where it belongs. And so since that's an even number, it is an even permutation. Now here is a different case, and on the other hand, this one would be an odd permutation. And the way that we can recognize an odd permutation is to note that only 2 of the triangles are incorrect, but a third one is placed correctly. Note that in order to solve the permutations of these, you would have to do an odd number of 2 swaps, namely just a single 2 swap, to place the triangles back over their appropriate slots. Recognizing even and odd permutations will become quite important later on within this video. It is definitely a more advanced concept, but I do want to go ahead and put it here, just so that it's with the other definitions. Alright, now let's go ahead and finally get started with some basic tips that you can use to help improve your last 3 triples. So here's an example case. As you can see, we already have 1 pair completed, and it's on the top here, and we want to form a second pair. Now, in this situation, we can see that there are actually no other second pairs to be formed, and the reason is because the other corner that is oriented is this one, and this has a, in my case, magenta sticker facing down, so we would need the magenta triangle to be down in order to be able to actually match it up here, but we can see that it's on top. So what that tells me is that I have no choice but to flip before I can continue to form another pair. In general, when you're completing your second pair for last 3 triples, you will always be using the oriented corner to form the next pair. And so whatever color happens to be facing down, that's the triangle that you want to be on the bottom. In this case, though, we don't have that. We can't form any more pairs. So you might think, well, we could try to flip this pink triangle to the bottom. But we actually can't do that either. The reason is because we have to remember to preserve this pair we already formed. So that means we must flip these other 2 triples. But you can see that since the other 2 triples contain both of these pink pieces, if we try to flip that over, we're not going to end up with both pinks on bottom. So what does that mean? Well, it means that we actually don't want to even solve pink at all here. We have to go with the other color, the third one, which in my case is going to be yellow. And you can see that this will actually work. We do have a yellow triangle on the bottom here, and so what we'll do is we'll take this pair that we have preserved and place it over that triangle. Now, when we go to flip the other 2 triples, we're going to be flipping the yellow corner to the bottom, whilst the yellow triangle will stay on the bottom, as we can see here. And now we can actually match this up and make this pair. If you follow these sorts of guidelines, you should pretty much be able to eliminate any redundant flips that achieve pretty much nothing to help you out. Every single time you do a flip, you should either be setting up a pair to be formed or bringing a pair that you have just formed up to the top to be preserved. Ultimately, this is something that you will just get better at with practice, and just do a lot of solves keeping that mentality in mind, and then eventually you'll start to get the hang of it. Now, something else I would like to talk about is choosing the correct flip alg to use in certain cases. And you might think, well, it doesn't make a difference, right? Whichever flip alg you use, it's going to flip the same 2 triples over. Does it really make any difference? So in this case, I have, again, this pair here, and I just formed this pink pair on the bottom. So we're ready to flip this up to the top, and we also have the other 2 on top ready to flip over. And we have 2 choices here. We could either flip these with a hedge, which would set up to this case, and then we can finish the pair formation. Or the alternative is to finish with a sledge, and again, finish the pair formation. Notice that both of these give the same outcome at the end, even with your final case to solve the rest of the puzzle. You can see that in both of those cases, we would be able to skip the corner permutation with the finish. And this is true whenever we form that second pair. There will be no difference whether you use a hedge or a sledge with the final outcome. So again, you might be thinking it shouldn't make a difference, right? You should be able to use either one. And it actually does from an ergonomic standpoint, and it has to do with where that last triangle is going to end up. From this angle, if we were to do a hedge algorithm, it would place this triangle right here. And we can see that, and then we would do a U move, and then the pair formation would be completed from this angle. But this is not an ideal angle, right? In order to finish this, we would have to rotate the whole puzzle, and then do our final algorithm to finish the whole thing. So we don't like that reorientation, right? How can we eliminate it? Well, if we do a sledge here, it will take the last triangle and it will place it in the back left slot. And now when we do a U move to finish the pair formation, we already have our two misoriented triples on the right, and we can go straight into the final flip alg without having to reorient the puzzle at all. So what does this mean? It means that in general, you should try to aim for your second to last flip algorithm to place the last triangle in the back left slot. That way, you can instantly form your pair formation and go straight into your triangle permutation flip. This will definitely save you reorienting the puzzle and quite a bit of time, and make the execution a lot smoother. Now, let's talk about two flip. This is the case that comes up sometimes that people don't like and that you really don't want to have, where you have all of your pairs formed, however, the triangles are located directly above their slots. And you can't solve this immediately, you have to do two flips to solve this, as you can see here. So the question becomes, is there a way to avoid this situation? And there actually is, and it's actually really easy. Alright, so here's an example. So I have this pair completed, and I just formed this pair over here, and now we're ready to flip these two and finish the pair formation. Now something important to note with the two flip case is that really the reason that you get your two flip case is because the last pair that you formed ended up in its correct slot with this triangle. As you might be able to see, that's going to force the other two to also be correct above their slots and give you two flip. So the easy way to avoid it is to simply avoid this last unpaired triangle from ending up in its correct slot prematurely. And again, remember that whenever we do our flipping algorithms, we have two choices. We can either use a hedge or a sledge. So ultimately, avoiding two flip comes down to using the correct flipping algorithm such that your last unpaired triangle ends up in a different slot than where it should belong. So what that means is that for this case, we actually don't want to use a sledge. Even though that does put the triangle in the back left slot, which I had mentioned earlier is usually better to get, in this case it's actually worse because we end up with two flip. So what this means is that we should actually be using a hedge to solve this one. So if we use a hedge to flip these two triples, this triangle is going to end up here in the light blue slot, which is not where it normally belongs. And now, as you can see when we finish the pair formation, we have avoided the two flip case entirely, and we can go ahead and finish with just a single flip. Really try to avoid two flip cases at all costs. It is objectively more efficient because you will always have to do one less flip each time. And this includes getting pure two flip solutions for the very end when you skip corners. So remember to track that last unpaired triangle and make sure it does not end up in its correct slot prematurely. Now, of course, sometimes that isn't always going to happen. Sometimes when you get to your last three triples, your case just happens to be a two flip case. So what's the best way to solve it if you get stuck here? Well, you want to hold the two flipped triples in the back like this, and the solution for this is very simply just a hedge followed by a sledge. Doing it this way avoids any rotations, and you can go into the two sequences quite quickly. Alright, so now I would like to show a few special last three triples cases that you might see come up, where you can actually use an algorithm of sorts to make it just go a little bit faster. Here's one of those cases that you might see. You have all of these pairs formed, but they're flipped to the bottom and in their wrong slots. Note that this is not a CP case because these bottom triangles are permuted incorrectly relative to their positions. So this is the first case. For this one, these three triples all need to cycle clockwise, as you may be able to see here. Now this can be solved with two flips, but there is a nice way to cancel them into each other and save some moves, and here is the full sequence for that. So we're going to hold the puzzle in flip grip like this, with this face facing towards us, and this is F and U, and the algorithm is the following. Here's the other case of this form, where the three triples need to cycle counterclockwise. This time we're going to hold it with flip grip with the front face towards us, and then kind of off to the side, as if we were executing a CP alg. So this is F and this is U, and the sequence goes like this. And quite unfortunately, that's pretty much it for easy, quick algorithms. The rest of the cases I'm going to show now are going to be commutators or some other advanced tricks to help out very specific cases. Now let's move on to some simple commutators that are actually quite useful to know and can help you get out of certain cases. Here's the first one. We have just 3 bottom triangles that need to cycle with 1 top triangle like this. The arrangement is pretty easy to see here. It's these 3 look from this perspective. So the first case is where the 3 triangles need to cycle clockwise from this perspective. So we hold it with the 2 bottom triangles on the right like this, and from this perspective, and the sequence goes like this. And the other case, where they now need to cycle counterclockwise, is simply the inverse, which goes like this. The nice thing is that you can actually use both of these commutators in conjunction with a CP case. So here I could solve these 3 triangles first. And then finish with CP. Here's another one that you might run into. What we see here is that we have all of our bottom triangles placed, but these 2 are swapped. This would actually be another example of an odd permutation on our triangles. There's another easy commutator for this one. To solve this, we want to hold the puzzle from this angle. This is kind of hard to see, but you have 1 unsolved bottom triangle on the right and a solved one on the left, with this being the front face. So we're basically holding it upside down. And the sequence goes like this. And also, for this case, if you have corners, you can do the same sort of thing. First fixing the bottom triangles, and then doing the CP. Now, there is one more case that I would like to show here that is pretty specific, but it can come up sometimes, and there is a nice 8-move sequence to finish it relatively quickly. So this is actually the dreaded 1-flip case, and we do get this quite a lot, and most of the time it's not very fun to deal with, but in a very specific situation there is a quick 8-move algorithm to actually get us out of it and straight into corner permutation. So you know you'll have it if you end up with 1 flip, but your 2 bottom triangles are solved. Note that this will not always happen. Sometimes the bottom triangles will be in their incorrect slots and you'll still have a 1-flip case. But in the 1/3 chance where this does happen, there is a very nice algorithm we can use to fix this. Now this does take quite a bit of getting used to, but the setup is to take the solved pair that we have here and place it over the good triangle. So remember when I talked about 1-flip in my beginner's tutorial that you want to rotate this pair over the remaining bad triangle and then do your flips to get out of it? This works the opposite. You want to take this pair and place it over the good triangle like so. So this is our setup, and now all that we really have to notice here is that this situation can be solved with an 8-move commutator with this corner pair, and this corner pair. So for this version of the case, we place the gray pair on top, and this is going to go in this position and interchange with this. So the algorithm goes like this. We're going to hold the top layer on the front face, and the sequence is the following. And now as you can see, we just have corner permutation left, and we can go ahead and solve that. Here is the other version of the case, which is where, again, we have 1 flip, but it's the mirror image, so it's this corner that is twisted instead of this one. And again, we take this finished pair and rotate it over the good triangle. This time we're going to place this pair on top here. So again, holding this top layer on front, but now the bottom triangle pair is at the top here. And again, the cycle goes with this pair, and this pair. But this time we do the inverse algorithm. And again, we're left with CP, and we can finish with the CPL. So that case takes quite a bit of getting used to, recognizing and executing quickly, but it is definitely more efficient than doing 3 flips to get to CP. Now, sometimes one flip is simply unavoidable, and when you get to the last 3 triples, you might just happen to have a 1 flip case as your given permutation. So what's the best way to solve 1 flip efficiently and quickly? Well, there is a nice way to do it. As I've mentioned in the past, what we want to do is rotate the solved pair on top over the bad triangle as a setup, and then we want to flip the other 2 triples. But is there a way to do this next flip to optimize our execution? It turns out there is. There are 2 possibilities, depending on whether you have a right or left-handed version of the case. For both of these, we're going to hold the puzzle so that the pair that we have finished is in the back left, and that bad triangle is already matched up underneath it. And this is the first case that we have where this corner over here in the back right is the twisted corner. For this case, what we want to do is use a sledge, and we'll actually be using 2 of them to complete the whole pair formation, and I will demonstrate that here. So we want to first do a sledge, and then we do a U prime, and that matches up the other pair, and then gets these 2 ready to be flipped. So then we can do another sledge, and then finish the pair formation from there. Now, you don't always want to do a sledge for that second flip, and again, that's because that flip is the second to last one you do before you do the one to complete the triangle permutation, and again, you want to avoid getting 2 flip cases. So for this example here, if we again have the same case and we set it up, and we start off with our first flip, which is a sledge, as I said, and then do a U prime, this time we don't want to actually do a sledge for this next flip. As you can see, that would place this pink triangle in its slot, which we don't want. So instead, we're going to use a hedge to avoid the 2 flip case. And here is the other possibility, where if we go ahead and place the pair over the bad triangle and put this pair in the back left, we see that the twisted corner this time is facing towards us. For this case, our first flip is going to be a hedge instead, followed by a U move. So if we do that here, we do hedge, then U, it automatically sets up this pair, and these are now ready to flip, and we can do another hedge, going straight into that, and pair formation is done. And just like with the other case, we don't necessarily want to do a hedge for that second flip. Sometimes we want to do a sledge instead to avoid a 2 flip case, and here's an example of that. So we can see again the twisted corner is towards us, so we do a hedge, and then U. And now we could do a hedge, but that's going to give us 2 flip, which we don't want. So we'll do a sledge instead, and a U again. And now we only have a 1 flip solution for the triangle permutation. Alright, it is now finally time for me to talk about one of the most helpful tricks to use to shorten your solutions for last 3 triples, and that is offset pair formation, or OPF. This is where we complete our pair formation in an offset way, so that our bottom triangle corner pairs don't match up exactly, but we're still using bottom triangles with the corners. So here is an example of a completed offset pair formation to show what it looks like. So what we can see here is that we have the bottom triangles still matched up with the corner pieces on the non-top colors. So in this case, it's not gray, it's the bottom colors. But the difference between this and a standard pair formation is that none of these colors are actually directly matching with each other, and everything is off by a 3 cycle. In fact, it looks almost completely scrambled in this state. But here's the magic. If we go ahead and complete the triangle permutation step, watch what happens. We still end up with all the bottom triangles permuted correctly, and the corner pieces oriented, and they just need to be permuted. So therefore, it can still achieve the same results as with standard pair formation. So this effectively means that we have 3 times as many options to form our triples compared to just the one standard way. And hence the solutions are often much shorter. In my opinion, the best way to understand OPF is to understand it as a pre-move. Now, if you aren't familiar with pre-moves, they are effectively moves that you apply to the puzzle prior to a solution, which makes everything offset. And this is normally found in the fewest moves category of solving puzzles, but that's really what this is. So to kind of help you see it here, let's say that I undo a flipping alg in the solve state. We see that we get a regular standard pair formation. And I'm sure you've been doing this for a while and understand the concept of how this works. But now, let's say that I apply some AUF to this top layer here, and then undo a flipping alg for triangle permutation. You can see that we end up with an OPF. So that's really all this is doing. It's applying a pre-move into our solution for the last three triples. So that way, when we finish permuting everything, we just have to undo that pre-move at the very end. Alright, so let's now talk about how to actually do OPF and recognize it, because this is where most of the learning has to happen. The basic idea is this: when you form your first pair with OPF, you can use any corner piece and any bottom triangle. So, as an example here, this would be a valid OPF for the first pair. We're using a corner piece with a bottom triangle, and they are matched up like this. So whenever we have something like this, we can then treat it just like a regular pair that we would normally form. So I'll go ahead and now flip this to the top here. So now we have this first pair actually done. Now when we form our second pair, it is a little bit different. We have to be careful to not accidentally pair them off by a 2 swap, because if we do that, we get a really bad case. But in order to prevent that, it's very easy. We just want to look at what the two colors are in our first offset pair that we formed. And for the second pair that we formed, we simply want to use the third missing color. So for my case, I used light blue and pink for this first pair. So therefore, I need to use yellow somehow in my second pair, either with the triangle or with the corner. Well, in my case, I do have the yellow triangle down here, which is really nice. So all I have to do is match it up with a corner piece. And the other important thing is that when you match these up, they always have to mismatch. So you can't make an offset pair and then make a regular pair. That will not work. So this right here would be a valid second pair because we are using the third color that was missing, in this case yellow, and these do not match. So now that we have this pair formed, we can then go ahead and flip this to the top. The great thing is that the rest of the recognition for things like avoiding 2-flip or permuting our triangles actually works exactly the same way. So in my case, this is the third unpaired triangle, and to avoid a 2-flip case, I want to make sure that this does not end up in its solved slot prematurely. So here I don't want to use a hedge because that would make it go into that slot. So instead I'll choose to do a sledge here. And now we have 2 offset pairs finished. And now to finish the pair formation, we just match up this last one right here. So now we are on the triangle permutation stage, and again, the recognition for this works exactly the same way. In my case, I have the yellow triangle over here, and this front color is yellow. So since this has to go to the front, this is going to be a sledge. So we'll go ahead and do a sledge to finish the triangle permutation. And now we have that done. So again, pretty straightforward and very similar to what we were doing already before. However, this now, when we get to corner permutation, is where things do change slightly, and it is very important to note this. Previously, the way that I would recognize corner permutation, or I guess which alg to use for the corner permutation step, is to look at what my AUF was, and then I know that the first move of the algorithm starts with a move in the same direction. But now with OPF, this is actually going to be the opposite. So in this case, I have to do an R prime to align the layer. So what that means is that I actually have the counterclockwise CP alg, and that's going to start with a clockwise move, namely F, as we can see here. The reason this happens is because, as said before, we're effectively applying a pre-move to the puzzle, and when we get to the corner permutation, that gets absorbed into the layer orientation, which is what causes that effect. So that was a quick example of using OPF in a solve. And now I would like to show an example where this technique really shines and proves its importance and helpfulness. So here's just some last three triples case that I happen to have here. So if we were solving this case normally with standard pair formation, well, we have no pairs yet. So we would have to, let's see, okay, we can match up this one, and then we would have to flip these two and then match this one. So we wouldn't have any pairs at all. However, with OPF, we can see that we actually already have a pair that's formed on top, which is great. And hey, look, we already have this pair over here that is also matched up correctly. Again, it follows that rule of using all 3 colors within these 2 pairs, and none of them directly match with each other. So all we'd actually have to do is flip this pair to the top. So if we go ahead and do that, we have two completed pairs on top, and then we can go ahead and finish the pair formation just like that. So the pair formation was done with only one flip. This is really the advantage of using this technique. It gives you many more options for your first and second pairs that you can use with the pair formation step. And then we could go ahead and of course finish this. And amazingly, when we finish this triangle permutation, it completely solves the last layer, and a single U move finishes it, and we skipped corner permutation. So you can also get situations like that, which are quite nice. Now you don't skip corner permutation every time. In fact, it's the same probability as before a third of the time, but it's really fun to see it happen when it does. Now back on the topic of one flip. So as I've shown before, when you get a one flip case, you really just kind of have to push through it. But there are other cases within last three triples that lead into one flip. And if we can recognize these cases and use a proper solution, then it gives us an avenue to be able to avoid one flip in a lot of circumstances. Note that avoiding one flip in this way requires us to use OPF. Yet again, OPF proving that it is a very powerful technique here. And there are 5 total cases for this, and I will be going over each of them now. Here is the first case that we will see. We have all of our corners oriented. We have 2 of the bottom triangles on our top face, and they are in an even permutation state. Whenever you run into this case, to avoid one flip, the rule is very simple. We simply don't want to flip both of these triangles to the bottom when we have our pair formed. So this is an example of doing it wrong. If we flip both of these to the bottom, you will see that we end up with one flip. So instead, when we form a pair with this bottom triangle here, we don't want to flip both of these triangles. So in other words, instead of flipping these two, we should actually be flipping these two. So if we do that, you can see this time we do not get a one flip situation, and it is a much more efficient finish. Here is another case. This one has all corners oriented and only one bottom triangle on top this time, and the triangles are in an odd permutation state. And again, the way we recognize that is one of them is solved, while the other two are unsolved relative to their slots. They would need to be swapped over. If you run into this case, we want to rotate this top layer here so that we place the lone triangle over the empty slot, just like this. So it is away from the other two triangles. Once here, we then want to choose either this pair or this pair to flip to the top. It really doesn't matter. In this case, I'll do it as a standard pair formation, but keep in mind OPF still works here. So we'll flip these two. And now that avoids the one flip case. Here is a third scenario, very similar to the previous case, except this time the two corners that are not connected to this bottom triangle that's on the top face here are twisted. What we want to do for this case is form a pair using our oriented corner, so we can either form the pair here or form the pair here. It really doesn't matter. And this time we do want to flip both of these bottom triangles to the top face. So we want to flip these two triples, so we can go ahead and do that here. And I'm just going to do an OPF solution here because why not? And now finishing this up, this will avoid a one flip scenario. Here is the fourth case. This is an interesting one. What we have is almost a completed pair formation actually, except you can imagine that this top center is sort of twisted away from it. If we were to cycle this triangle to clockwise to here, this one clockwise to here, and this one back to here, we would actually have a completed pair formation. At least this is how I recognize it. So first let me show the wrong way to do that, which would be to take this pair and flip it up to the top while flipping these two pinks to the bottom. This, as you can see, gives us one flip. So for this scenario, what we actually want to do is to look at our top face, and we see this pair here. Now this might not be an OPF pair, it depends on your triangle permutation that you have, but you have this pair here. What we want to do is assume this is our first pair, and then we want to form a second pair using this bottom triangle. So what we'll do is we'll rotate this pair over this triangle here, and then flip the other two triples, and then continue with pair formation as normal. And we can see this avoids one flip. And finally, this is the last case that can lead into a one flip situation, which is where you have almost a pair formation completed again, except your triangles are actually in an odd permutation state. You can see that if we were to swap these two triangles, we would have a correct pair formation. Very unfortunately, this case is pretty awful, and no matter what you do, you'll find yourself running into a one flip case, but the best way that I have found to solve it is the following. We choose one of these two top pairs, it really doesn't matter which one, in this case I'll choose this one, and turn it over the triangle that's on the bottom here. Then, we want to flip the other two triples, but we want to do so in a way that this triangle, this remaining triangle over here, gets placed into its correct slot. Now, sometimes this actually isn't even possible, and in which case it's bad and just take the one flip, honestly, because it's pretty bad. At some point I would like to really find an algorithm to deal with this case better, but this is what we have for now. So in this case that's going to be a hedge. And now what we have is a direct setup into that 8-move solution that I showed earlier for getting out of one flip when you have your triangles solved. And so we can go ahead and do that. And then we're just left with CP. I do highly recommend learning each of those 5 cases when they do come up, because if you can avoid one flip, you're always going to be more efficient. It does take a lot more practice than avoiding 2 flip, for sure, and is a lot more complicated, but it's definitely worth it. Now there is one more case that I would just like to briefly talk about here that you might run into, and that is a situation where you can actually form 2 pairs at the same time. It's not extremely common, but when it comes up, you definitely want to take advantage of it. So here's an example of what a case like that might look like. So we have both of these bottom triangles on the bottom right here. And when you run into this, you might, just see this corner and this triangle here paired up, and so you might think to just flip that to the top as your first pair. But as you can see, this is actually a pretty bad way to solve this, and we can be much more efficient about it. Remembering that if we have an even permutation on all of our triangles and 2 of them are on the bottom, if all of our corners are oriented, then that means that any top layer twist like this is actually an equivalent proper pair formation with these 2 triangles. So for such a case, it is best to flip both of these triangles to the top so that we have 2 completed pairs. Now it's important to also remember that you're going to have another bottom triangle on top as well, and you do want to flip that to the bottom when you do this. So if you were to have it over here, let's say, and then flip these to the top, then clearly that's going to be bad. So just make sure that if you do get a situation like that, that you're also flipping this triangle to the bottom. You might have to choose an OPF in order to achieve that, so keep it in mind. But as you can see, if we do this, we'll already have 2 pairs on top instantly. And just like before, the same rules for avoiding 2 flip also apply. We don't want this triangle to end up in its solved slot prematurely. So for this case, we actually want to use a sledge to avoid that. And then there we go. Pair formation completed in just 1 flip. Alright, so now I think it's time for a quick example walkthrough solve of the last 3 triples using all of those techniques and things that we've been keeping in mind to really try to bring everything home. So let's analyze this case that we have. So what I see on top here is we actually already have an offset pair formed, which is quite nice, so we can go ahead and choose this to be our first pair. And then looking around here, it also might look like that we have a second pair formed as well. But we actually don't, and this is because this is not a correct offset pair that we can actually use. Since this pair does not use the third color, in this case for me light blue, this is actually going to create a 2-swap situation, and we will get an odd permutation for triangles, which is wrong. So we have 2 options here. We can either pair this corner with the light blue triangle down here, or we could even try and pair this light blue corner with the pink triangle down here. Now the light blue triangle looks pretty enticing, but as you can see, this is actually a 1 flip case, and so this isn't going to be very good because if we tried to flip this to the top, we'd get the third triangle on top, which we don't want. Therefore, the best solution for this particular situation is to bring this pair over this triangle here and flip the other 2 triples so that we're pairing this light blue corner with the pink triangle. So we'll go ahead and do a flip to do that. And there's that set up there. And now in this case, we want to flip these 2 triples over. And again, keeping track of that last triangle. In this case, we actually get a pretty nice situation because it doesn't matter if we use a hedge or a sledge. The light blue slot is not over here, so it really doesn't matter which one we use. However, for ergonomics sake, as I mentioned before, it's usually better to place it here. So I'm going to use a hedge for this case. And now we have done that. And then finally, a U prime will complete the pair formation. And now this triangle permutation requires a sledge, so we'll go ahead and do that. And then we are finally left with CP. Now I can see that the AUF here is an R prime, and because we used OPF, that means we have the counterclockwise algorithm that we need to apply, and so that starts with a clockwise F turn. So we can go straight into that. And it's done. So I hope this helped illustrate all the techniques that I use for last through triples to really help improve efficiency in a solve. Like I said at the beginning of this video, I really hope you didn't watch this whole thing straight through once for the first time, because these techniques need to be learned over time, and you need to practice them slowly, one at a time, before you can move on to the more advanced stuff that I covered later in this video itself. So take the practice slowly but surely, and eventually you will get the hang of it, and your efficiency will improve over time with these techniques. Good luck! That's it for this video. Be sure to check out the others through the playlist link in the description.